In this video, we will write a C language program for stack using linked list. Stack linked list, and the language is C language. Project is ready. Now for implementing a stack using linked list, first of all I should have a linked list. So even I can use the existing program for linked list. Already we have written the program for linked list. That same functions I can use them here, but I will write them again here. Struct node. First of all, I should have a structure for node. We should have some data and also a pointer to next node. So it's structure node and the pointer name is next. So this is a definition of node of a linked list. Then here a top pointer I need. So top pointer I will take it as a global variable and I will initialize it as null. So even I can declare it inside main function and pass it as parameter to the functions. Otherwise, taking it as global, if I have only one stack in my program, then I can go for this method. Though this is not recommended, we should have a pointer inside the main function and we should pass it as parameter to the other functions. Now the functions that I should have are push and pop. So I will write on only three functions, that is push, pop and peek functions. Void push function. This push function should take a value to be inserted and we should push it into the stack. So let us implement this function. So this function should first of all create a new node, struct node, using a temporary pointer t, and a t assign. I should create it using malloc function. I should create it using malloc function struct node. This is a typecasting, and call the malloc function, and how much size I need, I should mention a structure name. So this will create a node. Then t's data should then before pushing I should check whether the stack is full. Here the stack is not having any size, so if node is not created, it means the stack is full, or actually heap is full. So I can give a message, that stack is full or stack is full. And also I'll give a new line. Otherwise I can insert a node. So for inserting a node, already I have created a node, then I should set the data for this node as x and set the next pointer as top, and top should be pointing onto this node t. Yeah, one thing, I should do all these things inside else part, that is if stack is not full, then I should do all these things. This should be enclosed inside else. Yes, I have done it. Now the next function is pop function, which will delete the topmost element from the stack and it will return that element. So for deletion, first of all, it should check whether the stack is empty. If top is equals to null, then the stack is empty. We cannot delete any element. So it can print a message that stack is empty. A new line. Else we can delete an element. So for deleting an element, I need a temporary pointer. So I will take a temporary pointer, struct node star t as a temporary pointer. Then t should be pointing on the top node, that is topmost node. Then top should move to the next node, top assign tops next. Then take out the value that whatever we want to delete, that is then take out the value from the topmost node. So t's data, t is pointing on that node. Then free that node t, delete that node. And for this I need one more variable, integer x, and which is initialized to -1. This will take the deleted element and it will return it. So at the end I should say return x, value x is returned. That's all, two functions I have written. Now the last function is display function. So void display function. This will display all the elements. So for that I have to scan through a linked list. So for that I have taken a temporary pointer p for scanning through a linked list. Then p assign top Then while p is not equal to null, that is p is not equal to null, I should scan through a linked list and display each and every element. So printf percentile d, give some space, and I should display the elements using pointer p's data. And after displaying all the elements, I should give a new line. So for formatted output, I'll give a new line. That's all. All these functions are ready. Now I can use main function. Yeah, and one more thing, while it is scanning through a linked list, then P should move to a next node. Inside the main function, I will call few functions for pushing and popping the elements and also displaying. So I don't have to create a stack because already I have taken a top pointer as a global variable. If I'm not declaring top here as a global variable, then all these functions must take parameter as a stack. So I made it as global, so directly I can call push and pop function. So let us call push function and push few values. 10. There is no upper limit, so there is no chance of stack getting filled because we have taken the limit as heap size, so that may be taking n number of elements. So I'm pushing 3 elements, then I will call display function. It should display all the elements. Then inside printf, I will call pop function and display its data. Pop function. So that's all with the main function. Let us check few things. Here, a top pointer I have declared, so this is accessible for all the function. This is a pointer, so I should make it as star. Actually, I missed this star. Then let us run the program. Yes, these are the elements when I display them, and the topmost element is 30, so I deleted that one. So pop has given me the element. So that's all. And for utilizing this stack, wherever if I need in my application, then I need this node structure and the top pointer that is declared in the top or as a global. Then I need push and pop functions. If I need any other function, I can write down that function for the stack. I can use these functions inside an application wherever stack is used. That's it.